Okay, so when you're going to evaluate a simple polynomial integral, okay, again, the ones we need are pretty simple. If you're in BC, you know how to do this, I'm sure. If you're in AB, you're going to get to this, but I think maybe in a little while, okay? And in regular calc, it's going to be a while, okay? So if you know how to do it correctly, that's great. And if you just kind of need to get through this part until you learn it correctly in calculus, then you basically just want to think of it like taking the derivative backwards, okay? So it would be basically like if I took the derivative of this, I would need to get this, okay? Integral is basically just doing it the other way, all right? And remember, this would be like if I had some kind of a velocity function, okay? Taking the integral just means I'm taking the area, okay? And mathematically, that's the integral, okay? So in order to take the integral, okay, so you write it, the integral v dt, all right, and then I'll plug in my velocity function here, okay, and you basically are trying to think about if you went the other direction, it would be the derivative, right? So you know when you take the derivative, the exponent goes down by 1, so when you take the integral, it has to go up by 1, okay? And then you also move that exponent to the front, right? So you're going to need to put the exponent underneath in order to get rid of it, right? Or to cancel out what would move down, all right? Every time you integrate, you also have to add a constant, okay? Which there's some more mathematical stuff about how to find that constant, but for us, most of the time, this x naught will just be 0, right? Because you don't really know, when you have a velocity function, you don't really know what the initial position was, right? So we just assume it starts at 0, okay?